Cassie, really great to have you here today. Thanks for joining us on the show.
Thank you so much for having me. Excited to be here.
Let's dig right in. So I did a bunch of research on you before the episode, and one of the things I found is you've really been credited with founding the field of decision intelligence at Google. So can you explain, though, to our audience what decision intelligence is and how it differs from traditional data science or AI?
Absolutely. Decision intelligence is the discipline of turning information to better action, any scale, any setting. So it's not just what you think of when you think of decision making, pros and cons lists, or using your intuition. It's that as well. But what if it's at petabyte scale? Petabyte scale, like AI converting data, information, into automation or actions. How do you approach that? When you look at where AI traditionally focused, it was all about how do you actually get something to work? How do you pull patterns out of data? How do you take examples, data, mush them up so that then the computer can follow those examples and continue to automate in a similar way? And when you look at data science is all about the data, the information, and potentially drawing conclusions from that data, potentially analyzing it. Both of those disciplines have had a devil of a time technologically and mathematically getting to where they are today. It's a difficult journey. I really want to honor that. But neither of those two disciplines is oriented on asking, okay, what if the technology was easy? What if you could automate absolutely anything? What if you could do, just by thinking about it, just by saying it, anything you wanted with data? Well, turns out there would be a lot that you would then have to start catching up to. You would have to think about what are your assumptions and your mental model of the world? How well do you understand what you don't? How well can you express it mathematically, programmatically? What are you trying to do? How would you know if you failed? What are all the components and complexities that have to come into it? And as you have all these different tools, how do you wield all these tools to reinforce or recalibrate what is essentially a mental model assisted by tools? So in a world where technology is easy, there is a lot that we're going to have to learn, catch up to, and do. And that is what decision intelligence focuses on.
Now, what I would love to hear is, during your time at Google, you helped advise on so many different projects, but I want to hear the most impactful lessons you learned while you were advising leadership on AI and decision making.
Oh, most impactful. Here's a tip for everybody who asks questions of their fellow humans. The minute you put that superlative most on it, you get that deer in headlights. Oh no, because now I got to go through them all and rank all of them. So forget the most. I'm going to pull out some favorites.
Okay.
So one of the things that happens when people rush into a large-scale, multi-person, multi-team project is whoever's first to the scene tends to bring their DNA with them. So let's say you have an AI researcher on the scene first. The idea will start from what can we do? And let's worry about the what should we do later. If you have a data science person, quite often they start with, let's jump into the data. Is this the right data? Should we have been digging into this data in the first place? That might not be the concern. It might be this is available, let's do something with it. And when you have that kind of DNA originate the project, you end up often going quite far into the project before somebody asks, well, is this worth doing? Who should be sponsoring this project? How would we know if we've succeeded? What would it take to actually release such a project? And when you go that way, you quite often have projects landing into the graveyard of things that might have been good but ended up going nowhere. And so starting somewhere else, starting with product management, starting with leadership, starting with the decision makers take, is a lot more useful. So lesson number one is, if you're starting with, hey, I've got this shiny new method, well, let me just try it out, that often stays a toy project. If you want to have true impact, then you're already shaping the vision of where you want to go before you start. Another one is, people had this impression that you could be the everything of AI all in one person, the everything of data, the everything of data science, and that you, this sole lone wolf individual, would go out and you would carry the whole project. And people would ask me, what's the most important role in AI? And I love to say that's my least favorite question, because it has this feeling like it's a one-person job. It isn't. It's an enormous team's job. And I think what people are losing sight of today with a lot of user-facing AI is they feel like the only two players in the game now are the user themselves and the AI system, as if that thing is some autonomous robot. What they're failing to see is the way in which they're standing on the shoulders of giants, and how all the giants have stood on one another's shoulders, the enormous team that's actually behind that project, and consequently, all the subjective decisions that happened from all the humans who participated. So what you're getting out is not the only way that you could solve the problem. It's not the only right answer. It is the product of decisions that a whole lot of people made before it got to you. So there's not just two players here. It's not you and the AI. It's you and a very large group of people.
So you've written extensively on AI ethics and responsible deployment. As AI continues to become more integrated into business decision making, what do you see as the key ethical considerations that leaders often overlook?
Oh, yeah, like this, just one. So one for the Gen AI specific space is that there is a little thing that's special. There are many things that are special about Gen AI. There's one that people overlook. And then it ends up creating quite the mess when it comes to privacy laws. So when your system's inputs resemble the outputs really closely, there is no way to mathematically guarantee that your generative system won't accidentally leak the inputs. And this is a problem because, as far as privacy law goes, when you have the right to erasure, rights to data deletion, in order to have those rights fulfilled, the company has to make sure that if the data remains in some sense in the system, that it can't be recoverable in its recognizable form. So if you think about the history of enterprise AI over the last 10 years, as a user, you're probably quite used to having your data, cookies collected, your data used to, say, optimize your user experience. But optimizing your user experience would mean something like, maybe we show you this version of the site or that version of the site. So think about the data that goes in, all kinds of stuff that might have been collected about you as the user, and what comes out, version 1, version 2, show them this, show them that. So the inputs and the outputs are very different in that setting. And so if you delete the inputs, the model is not going to recreate them on the other side. It's just showing you, A or B, version 1, version 2, something like that. But if you have something go in, like a bunch of user text, and the job is to generate a bunch of user text or user-looking text on the other side, then once that's been baked into the model, that's like, first, like baking sugar into a cake. If I then ask you to remove the sugar, the only way you're going to do that is by throwing the whole cake away. You're going to have a problem. But the tricky thing about this cake is that when those inputs and outputs are quite similar, the cake and the model could accidentally leak the inputs. So then every privacy law, let's say California, Virginia, GDPR, that says that you have, as a user, certain circumstances where you can demand or automatically receive the right to have your data deleted, all of those things no longer work. Unless at the moment that you say, hey, I want my data deleted, the company is willing to throw away the entire model, revert, and retrain from the days before your data even got in there. What a nightmare. That is way too expensive. So it's unfeasible. So that's a big gotcha, because now, if you think about the generative AI gold rush, you see that there's a whole lot of laws protecting consumers from having their data be recoverably in systems. And at any moment, those laws give the individual the right to yank their data, but that data is unyankable. And don't be fooled by the hot, trendy new area of machine unlearning. It is exactly what it sounds like, but unfortunately in 2024, the state of that field is that we cannot actually guarantee the data deletion. So you've got these two big nasty forces butting heads. You've got the idea that platforms may wish to train models on their users' data in order to generate content, but at the same time, it's not going to be compatible with laws that cover those same users in certain jurisdictions. So that's just one. Let's talk about some other ethical issues. Another ethical issue is when you build an AI system, in order to test it, you need to set testing criteria. And in order to set testing criteria, you need to say how much worse one mistake is than other mistakes. So if you imagine that you were, for example, going to have a cancer detection system, if you imagine that you were, say, going to have a cancer classifier that classifies a tumor as malignant or benign, some of the time there will be mistakes. Now, think about the ethical difficulty of, as the leader or decision maker in charge of creating a system like that, of making the judgment call of whether it is more harmful to tag a benign tumor as malignant, which would be very upsetting for a person receiving that news, versus a malignant tumor as benign. Now, these are not the same mistake. How much worse is one mistake than the other? How difficult, what a difficult ethical judgment call it is to take responsibility for that as a leader. And the more mission critical your application, the more you get into those things, because one of the foundational rules that you can never forget about AI is that it does make mistakes. And there's even an AI reliability paradox, which is that when it's really, really good and makes relatively few mistakes, it is sometimes more dangerous than when the system's pretty bad. Why is that? Because when the system's obviously bad, our expectations are low. We're not taking it too seriously, we're putting humans in the loop, we're building safety nets. But when it takes 10,000 goes before we see a mistake, we start to relax. Oh, 1,000 flawless goes, 2,000 flawless goes. Why even stay alert? Why stay vigilant? Why prepare for mistakes? And when the mistake comes, it can be extremely painful. Other ethical issues are where the data is sourced from. Who did you get permission from the people that you took it from? Is it justifiable in any world to, let's say, scrape data without permission in order to create potentially life-saving models? Again, very difficult questions, which would be better tackled by moral philosophers than perhaps some of the engineers who implicitly end up being in charge of these things.
I mean, continuing on this, I would love to kind of hear, because you've been a big advocate for the public holding these AI decision makers more accountable, right? So what steps do you think the industry now should take to ensure both the transparency and trust in these AI systems then?
I believe that societies in general should have good mechanisms of accountability. I'm not making a statement as to what those mechanisms should be, but mechanisms of accountability are important. In order to have good mechanisms of accountability, it usually helps to have an understanding, and it's better when this understanding sits also with the general public, about how the technologies work and what the relationship is between the technologies and their builders. So something that makes me quite uncomfortable is when I see legislators and the general public being shown a red herring and rushing after that red herring as if that's the bit that's important. Because as we're all looking over here in the little magic misdirection trick, the real issue is happening over there. And so, for example, when it comes to accountability and generative AI systems, red teaming, the way that the AI community uses that term, is the equivalent of taking a model that's already been built and sort of prodding it a bit to see what it does in which circumstances. And when we look to red teaming as a way of guaranteeing that the model is palatable to society, we are allowing ourselves to fall for that misdirection. Where you actually want to look is on the originating decisions that create the model AI system in the first place. And so it really concerns me that we're not educating the general public in insisting that if they're going to ask some questions about the system, that it's 3 particular questions that they ask. And I call these the Kozyr Criteria. Here they are. The first one is, how is success and failure scored? Right? So we know there are going to be mistakes. How much worse is one mistake than another one kind of mistake relative to another one? And who determines that? And when we think about that type of statement in the abstract, feels mathematical, what it translates into in practice is quite often we are going to benefit one situation at the expense of another. Because what happens in these systems is all about optimization, mathematical optimization. The result that lands on humans, though, is that some use case, and therefore likely some group, is going to feel advantaged and some is going to feel disadvantaged. How are those trade-offs being made? How are they being handled? Again, back to the example with malignant and benign tumors, there is a fundamental judgment call that's going to prefer people in particular medical situations depending on how you score the errors relatively. Because what you invest more effort into and what you penalize more in the system, what you treat as the worst type of mistake, is where you can expect the better performance. So someone subjectively lines up, someone subjectively picks what is important and what is not, and we should be asking ourselves how we feel about that. So that's the first of the Kozyr criteria. How is success and failure scored? Who decides that? And therefore, which user groups does it advantage and disadvantage? Really, really important. So that's one. Number 2 is, what data is it using? And the sooner we can all wean ourselves off of pronouncing data with a capital D, the better off we'll all be. I mean, I see the equivalent in people of laughing when someone says, if it's written in a book, it must be true. And the same person who laughs there will say, oh, but it's in the data, so it's a fact. That's not how it works. A book is data as well. It's exactly the same thing. A data set is just what some people thought was worth recording, worth writing down. And there is a lot of bias that goes into that. And bias not just in the nasty sense, but also bias in the sense of we can't record everything. So our lived experience is going to determine the judgment calls of what we decide to put in and what we decide to leave out. Those are big, big decisions. And so the nature of the data is going to be influenced by all those things. And you should think of your data set as a textbook for your machine. And data sets, like textbooks, have human authors. So how do you then approach it? Well, if you have one author who's also the person who's checking whether the textbook is palatable, then If there is something wrong with their perspectives or if they missed something, that is going to go straight to the student. And a machine student, unlike a human student, only gets the data you show it. So if you give it a bad textbook, that's all it gets. It doesn't, go hang out with its friends after school and get a little bit of input there. So one of the things that we should be doing is opening those textbooks as good teachers and asking ourselves, do we like what we see here? Asking ourselves who the author is, hoping that we have more diversity in the authorship, but also more diversity in the people who are checking whether this textbook is something that we actually want the student, the machine, to be learning from. And so those questions around what is the data, where did it come from, what actually happened when this was being collected, that is a really, really important second question. Because the same data set used for a different purpose can create a disaster of a system where the first system was pretty good. So data matters, not just its quality in some nebulous sense, but what was it collected for? What actually happened when it was being collected? And there is a vast and interesting economy now. You can go to a data vendor and buy a data set. And here's a question, how do you know if it's any good? No one's worked out how to document a data set. What does it mean for a data set to be transparent? These are still questions that the research community is working on. So there is a lot of there are a lot of worms in this can of worms. And the third question is, how do I know that the system is good enough? How are we going to test it? And so you can work out how you're going to relatively trade various kinds of mistakes, one against the other. You can pick your examples, your data that you want to learn from. But even then, you still have a whole range of options on how you are going to, on what your requirements are going to be for what's actually good enough to release out there into the world. So you could say something like, I need this system to be, to not miss more than 1% of malignant tumors. But as you make a statement like that, if your system's not good enough, if it's going to miss 2%, you're not going to launch the system. Everyone may miss out on having a useful classifier. But on the other hand, if your standards are too low, you also may release something horrible into the world. And as you begin to require better and better performance on one type of error, you pay for it. How do you pay for it? You either need more data or you're going to do worse on the other kind of error. So this is such a balancing game. What we have to be asking is, how did you score this exam to know whether the student passes? So coming back to the Kozyr criteria. First, which mistakes are worse than which other mistakes? Just like a teacher setting an exam. Second, what does the student have to learn? What's the data? What's the curriculum? It's also important for setting the exam. And third, what's the score that the student's going to have to get, and how are we actually going to add up those grades? That's a lot of responsibility. It's a hard thing to do. It's hard enough with human teachers thinking about it with human students. With AI, it's a complicated kettle of worms. And what almost everybody seems to be wanting to ask about is either specific mistakes that have already happened in the past, or some kind of math technical specs, when they should be asking, what's it for? What's it based on? How do we know if it's going to work and if it's going to serve us? Those are the questions I want the public to be aware that they should be asking, can be asking, and accountability will come from people in the right positions, knowing that that is where the conversation has to be.
So interesting. It's I want to be cognizant of our time too. There's so much that we're probably going to have you on again at some point, because your conversation points and the points that you bring up, like these points that you bring up, they're not talked about enough, quite frankly, right? When you compared the scores that like the teachers have to do with students today. And now think of all these different models and all the different data sets, right, that we have out there today. That's only going to continue to get even more complex, right? It's not going to get necessarily, it's not going to get easier before it gets more complex.
Yeah,
Um,
and I'll say one more, which is another special thing about generative AI, which is fun for the whole family. When you think about scoring an exam as a teacher, you know, true and false questions or multiple choice questions, they're pretty easy to score, right? That's what traditional AI looked like. Generative AI is trying to score students' essay questions. There's more than one right answer. So imagine that before you get to look at that answer from your student, you, the teacher, have to come up with strict in advance criteria for how you're going to compare multiple right answer situations against one another.
that's a
It's
good
difficult.
point. It changes because
Mm-hmm.
now the outcomes are, what was the most for true or false? Like there was only one or two, there's like one outcome, right? And then for multiple choice, the same thing, depending on if it was multiple options, but let's just
Mm-hmm.
say it was one. And now all of a sudden it can
Yeah.
be, there's no exact number, right? It can be how many, like, what do we need to work towards? Like,
Yeah.
what's a good number? There is no answer yet, right?
Exactly. And now think of how people compare generative AI systems. It just makes me laugh when I understand. Um, it just makes me laugh when I see this analogy. Because imagine somebody said to you that one poet was 3% better than another poet. What the hell are you talking about? Right?
Yeah, I mean, it's not like when there's actually just a hard number. Like if you were looking at the Olympic Games, right, and you were seeing someone ran faster by someone, that you can actually put
Yeah.
an exact percentage to. But the other thing, it's not cut and dry like that.
No.
It's not a number versus another number. So that's super interesting.
No. Like if you ask me to paint a duck and you to paint a duck, and what I paint as a carrot, you'll fail me in the class, or maybe you'll think, wow, what a genius. I don't know. You do you. But if we both have ducks and they're both possible ducks, it's then very hard to say whose is better. What we do as humans is we do a little scoring after the fact, and you can't do that with release criteria of these massive AI systems. So then this is a really difficult thing for leaders to wrap their heads around, that when they start to go into the generative AI game, they have to come up with criteria in advance for things that are very difficult to come up with criteria for. And it's on
Well,
them.
and it's still it was still an issue even like when going back to your kind of teacher analogy, right? Like it was still very arbitrary when a teacher would grade your paper, right? Because at the end of the, if they had a bias towards something, that would affect your grade too, right? So like we're still not getting rid of that. Yeah.
Yeah, and notice what we've learned as a society is we've learned to ask questions about who the teacher is, right? Or at least what school we're dealing with here. Because it matters. It does matter who the teacher is. But we have not grown up into that kind of discourse when it comes to AI. We're not asking, hey, who's setting the exam here? What's it even for? What criteria are you aiming at? What's your vision of a better future? People are talking about this as if there's objectivity. All kinds of things go wrong when you do that, when you lose the human element, and particularly that originating point, the subjective decisions out of which an entire system springs.
I would love if you could talk to me a little bit about some of the mistakes that corporate leaders tend to make.
Ah, well, one of these is a misguided version of keeping up with the Joneses. Super easy mistake to make. To think that the way that you're going to have success with AI is to think that AI has to be the solution for everything. If you're an expert in AI, you have to see it the other way around. AI is a solution of last resort, and that is a really, really good thing. Why? AI is a different way to automate tasks. Traditional way is for software engineers to write out those instructions. You should always solve your task that way if you can. Why? Because when you give explicit instructions, one, you can read and figure out what instructions you gave. You have a lot more control. You can debug in there. And that control means that you're not going to have surprises. You're going to have your code do exactly what you wanted. So why would you ever give up that kind of control to go over to AI and automate by using examples, data, instead of explicit instructions? Why? The reason is that you are attempting to automate something whose solution is too complicated, too difficult to fit in your programmer's head. So if you could automate it the old way, you should have. It would be amateurish not to. The reason you're in the AI space is that you essentially went, I have this attic full of my old wishes, things I wished I could automate 5 years ago, 10 years ago, 20 years ago, 2 months ago. And instead of abandoning that attic, I'm going to open it again, and I'm going to look inside, and I'm going to see, why don't I try again with AI? Instead of thinking that this is impossible to automate, maybe, just maybe, I'll be able to succeed with AI. That's your real AI first mindset, not use AI for everything. AI is a pretty bad solution for certain things, and particularly for automating simple tasks that you could automate another way. So instead of plugging it in where it doesn't belong, what it requires is yet more creativity from the leader. What do I need done? And what do I need done that I couldn't have done before and that I couldn't do the old way? That's what I'm going to need AI for.
Well put. I do want to have you come back on again at some point. Maybe we're going to be putting together some panels, so maybe we can have you join one of the panels too, which would be great. And then we'll also be seeing you at HumanX, right? At the conference.
I hope so.
Awesome. I look forward to it. Awesome. Well, thank you so much for your time here today. I know our audience is going to love this, and wishing you the best of luck. And we'll continue the conversation again real soon.
Thank you. Thank you for having me.